Ag Tire Talks Driving Yield Through Tire Technology, sponsored by Michelin Agriculture.
James Tushner with Ag Tire Talk here. I'm with Mehari Tekeste. He is the director of Soil Machine Dynamics Laboratory at Iowa State University, College of Agricultural and Life Sciences, and College of Engineering. So, Mehari, in the last program, you talked about how you were using new ways of assessing footprints and really with artificial soil as opposed to the standard hard surface flat plate. You talked about how it's really changed what the measurements look like because you're taking into account the physical dynamic differences of a track versus a tire. So let's lead in. We're going to talk about field testing, but let's talk about what the in-house testing data reveals to you that provides some insight into the field testing.
Yeah, so uh, as you know that soil types, soil conditions on cropping systems, they vary, they're not
Amen.
uniform. So it's not meant that the artificial soil data uh, will capture all the soil field conditions, but it allows to give, a configuration comparisons of either tire inflation pressure systems, track systems, or different machines. We've been
Yes.
doing on sprayers, which that sprayers would go into a field either pre-emergence or after emergence on a condition that's not favorable for soil compaction. So the intent is that the artificial soil measurements would allow to compare configurations.
Okay.
Now, the question is how much of the field conditions can be reproduced? So as part of
In-house.
our study, we compared rut depths on our Iowa soil after uh, field cultivation tillage, just to compare, by how much magnitude is the rut depth different field versus the artificial soil. The field
Okay.
condition was on a moisture close to what we call a little bit drier than a field capacity. So we had about 1/4 of an inch rut depth difference where the
Okay.
artificial soil was deeper. So
Okay.
in other words, in a benchmark, you would know by how much magnitude you're off. And then when you look at the soil particle size distribution, or we call it textural triangle in a USDA soil conservation systems, the artificial soil, mechanically speaking, is close to clay loam. It's within that center of the triangle. So we kind of benchmark it how far it is from a field conditions, reproducible field conditions, but it doesn't mean that it will cover all the field conditions. The main purpose is to compare configurations before you go to the field.
Yeah. So really what you can do with that is you do all the testing inside the lab. You kind of get an idea for what you're going to see out there. And then you go and put it to the test, right? We're real world infield. Is that correct?
That's correct.
Awesome.
Yep. I think one of the interesting thing that we all know this, and how low do you want to go on low tire inflation pressures? How low? We
Single digits,
cannot just
my man.
dial so many tire inflation pressures in the field. But if you know what configurations to compare from an indoor test, then you go to the field, you narrow down your experiments, you try to find if those configurations would show significant effects on field soil compaction measurement or crop yield.
That's a great point. A lot of times you get bogged down into so many different configurations and air pressures. You're like, where's you can't see the forest through the trees. Sounds like a great way to really narrow it down to get to the hardcore facts that you're looking to find. So, well, good. Any other points that you'd like to make on the in-house, in-lab artificial soil testing before you go to the field, before we get to the field study that we're going to talk about today?
I think that's the main thing. We started also measuring soil stress or soil pressure by burying a sensor deeper at 8 inches, 12 inches, and 20 inches in a controlled environment. This
Excellent.
is a new, we're starting to use this knowledge too. But that's going to be part of our future indoor laboratory testing where you measure how deep would compaction go for those different tire configurations or machine system configurations. Again, it's always to bring that concept of, can I do better configuration? Can I get a good reliable data? The footprint is on the top with 3D soil penetrated. And then with our sensors now, we are starting to bury them at 8-inch, 12-inch, and 20 inches to see how deep the compactions would go. It's a new program that we just started last spring. We will continue that as part of our control test.
Mahari, one of the things I love about what you're doing is you always strive to get, at the end of the day, real world results as opposed to really pie in the sky stuff that, really just data points. And seeing you go to 8 to 12, and did you say the last number was 20? Are you going down to 20 inches?
Yes, yeah, 20 inches.
Big deal.
It's
Because
new.
yeah, but
uh,
most people don't do it because that deep is where you're getting the axles really playing the big role. Up on the shallow, correct me if I'm wrong, it's more about the air pressure piece for the tires. Is that not correct?
That's correct. Yeah, yeah. So soil compaction is more influenced by axial load if you when you look at it deeper below
Amen.
a typical tillage depths. But tire inflation pressure, the effect is more on a shallow soil compaction.
Well, I tell you what, I am thrilled with what you got going on there. We're excited to see all of what you're doing. Getting some of the new data points out has really been exciting on the difference between really an artificial soil test and compared to a regular flat plate, how the artificial soil piece on the tires really showcases a significantly larger footprint because it takes into account the physical dynamics of a deflected tire. So, with that lead in, let's talk about this last in-field test that you did, taking it from standard pressures to the lower air pressures. So, what'd you do?
Yeah, the study that we did will be for field research on quantifying the impacts of soil compaction. So the main objective on this field study was to investigate the effects of tire inflation pressure settings of a row crop tractor equipped with IF tires and a
Or
central
standard?
commodity field planter equipped with VF tires on corn yield and soil physical properties, uh, soil con index, soil compaction, soil compenetrometer, and soil bulk density.
Perfect. One of the things I love about your test, Mahari, is it's real world. So we're taking a Deere 8R, we're taking a 24 row planter, and we're looking at 480, 80, 50 rear duals, 420, 85, 35, 420, 85 R34 fronts, duals, right? Standard to IF pressures. Then we're taking the planters, VF 295, 75 R225s, another very, very popular setup, right? Standard air pressures to VF air pressures. Man, I love to see this because there's a ton of these setups out there in the Midwest. So then let's just go to the next step of, okay, so you did the differences in air pressures. Um, what were the differences in air pressures and what did you find?
Yeah, so this was collaborative research uh, funded by Firestone Engineers, Central Tariff Precision Inflation. They're in Des Moines, Iowa. USDA and Iowa State is a research group at university and industry.
Uh-huh.
Yeah, so our focus was on 24 row planter, 30-inch row spacing, and mechanical front wheel drive duals, both front and rear, which is a typical configuration on a large farm
Very typical. It's
planting.
everywhere in the Midwest. Go ahead.
Yeah, so what we did as part of our study, we measured weights on axle on two configurations, transport configuration where you have the planter frame folded for road condition and get the weights on axle weights on the central weight supporting of the planter tires, and then and then the front and the rear axle of a John Deere 8310R mechanical front wheel drive
Yes, it's important
tractor.
on those having those center tires assessed from the implement standpoint because clearly all the weight's there, right? When they're have the seed bulk. So just a reminder on that as we push through and look at the differences between IFVF air pressures and standard. So yes, okay. So um, you've got your IFVF. You're at 22 psi. Um, at the lower inflation pressures, you were all the way up to um, 30 psi um, as well. Even really the highest setting you've got, you're going from 70 psi plantar center to the lower inflation pressure of 50. So like, so walk me through really we're talking about the difference of 20% air pressure on the IFs and 40% air pressure for the VFs. So what did that really create? What did that do for you?
Yeah, so maybe to go a little another point to make out is those front duals and rear duals of the tractor. The front were IF 420, 85 R30, 34,
Uh-huh.
and then the rear duals were IF 480, 80 R50.
Yes.
The planter tires, the VF 295, 75 R22 and a half.
Yes.
So you have the tire, you also have that transport configuration load, and then a field configuration load
Great
settings.
point.
Field is defined as a field speed where you're doing planting at 5 miles per hour for planting application, and then the frame is unfolded. So you have the weight distribution reproducing the field condition, the weight distribution uh, representing a transport configuration.
That's a great point. I'm
Knowing
glad you brought
all
that up.
those, yeah, knowing all those weight loads and the speeds, we created 3 levels of tire inflation pressure systems. One
Okay.
we call it high, what's called standard.
Mm-hmm.
So on the tractor, the front, the rear, the front with 15 psi, the rear was 34 psi. On the planter, the planter tire centers, uh, we had them at 70 psi, 70.
Right.
And then the IF VF is a table from the manufacturer for IF settings and VF settings for the planter for a road condition. And the front was, we call it middle tire inflation pressure systems. The front duals had 11 psi, the rear were 22 psi. The central tire inflation pressure system is you consider the field speed 5 miles per hour, and that gave us the lowest tire inflation pressure
Right.
on the
Okay. So let's just be
tractors.
clear on this. So you went from a standard, so on 70 psi, right, on that planter tire.
Planter, yes.
Then you went down to 42 psi VF ratings, but you didn't do it. You did it at transport speed and load, right? So it's basically like, hey, we don't have a CTIS, but we are going to trade out standard tires to VFs, and then you did an assessment at that air pressure, correct?
That's correct, yes.
And what did you find on that?
So that was 42 psi on the planter center tires. Uh,
Yes, huge
and then
difference.
when you set it for the CTIS central tire inflation pressure settings, where field is field speed, the planter tires on the center, uh, 4 of them were inflated to 35 psi.
Right. Well, it's a great point because, okay, so if you're just running your planner way it is on with standard tires, you're running 70 psi. That's really, really, really high, right? All you have to do is
Correct.
trade out to VF, you get to 42 psi, right? And what kind of yield increase were you seeing when you just traded out to VF air inflation pressures, Mehari?
Yeah, so if you look at this now, you have the tractor that's set from high to low tire inflation pressure systems. The high is on the rear axle. Let's just focus on that.
Yep.
34 psi on the high, and the low is 14 psi on the rear axle of the tractor. On the planter, the tire centers, we're changing it from 70 psi to 35 psi.
That's
The
for central
yield,
tire
we
inflation
measure
system.
yield on the center rows, the 6 rows, using specialized um, mass-based measurement of a combine harvester at Iowa State. What we found out was that the standard radial tire inflation pressure settings, which is the highest on both tractor IF and then the VF on the planters, had the lowest yield. And the IF tractor tires and the VF planter tires had 4.34% higher yield than the standard radial tire inflation pressure settings. That is, we're looking at 9.2 bushels per acre difference.
Okay.
And the least significant difference, to consider it as statistically significant, the yield had to exceed 8.37 bushels per acre. So statistically speaking, having IF tire inflation pressure settings on the tractor and VF on that planter had a gain 9.2 bushels per acre, equivalent to 4.34% yield gain.
Okay, so let's just run through it. So basically at a bottom line, from a bottom line standpoint, compared to standard, if you just trade out the IFVF tires, standard to IFVF, and you run it at regular transport, load, and speed, you found a 4.3% yield gain, correct?
Yes.
Okay, great. And that makes sense, right? Because you're going from on the planter, which is the highest compacting, highest air pressure, you're going from 70 to 42 psi in this particular situation. It's a massive, massive difference. Okay, great. So what you're saying is that if you take it one level down and you take the central tire inflation system in this particular scenario, right? You're going down from 42 psi to 35 psi, taking into account the slower speeds, right? And just taking into account the change in load. And with that, you were able to get a 4.5% increase in yield. Is that correct?
Yeah, 4.34, yes.
Okay. Right. 4.34 was the IF to VF. And then if you did the central tire inflation system, you got a 4.51% yield increase.
That's correct. Yeah, 4.51%, comparing the CTIS, the lowest tire inflation pressure for field speed, the lowest speed that you have compared to the standard radial tire inflation pressure. And that's equivalent to 9.6 bushels per acre.
Really, what this equates to, the bottom line scenario, it's really in many ways similar to a lot of the other research we've seen out there as far as just VF pickups being in that 4% yield increase range, right? But really, if you put it all together, you're looking at, in this particular scenario, all the scenarios differ of really, if you use the CTIS with the VFs, you take into account the different scenarios of load. In this particular application, you're looking at a 4.51% increase.
Yep, that's correct. This was from our study. It's replicated 3 times, and the study was corn on corn. We measured yields for 3 years. Our field, the dominant soil series is Canny Soil and Clarion. They're very typical soil series, range from clay loam to loam soil in central Iowa.
Well, very good. And that is a wrap.